One of the issues that we've seen with traditional monitoring, management and security devices is the number of logs and the amount of information that a security appliance would actually give to an administrator. You know, what artificial intelligence do you build into the system to cut through the noise, so to speak, and get down to where the issue is, to help that sysadmin?
So one of the traditional ways of approaching looking at system logs is you record everything forever, and you index and catalogue that forever. And that means that every time you have an issue, you start with a search query, and then you build up your kind of your troubleshooting, your forensics around that search query. And the more and more you've got logs everywhere, but you don't know how to search them. So that's where you start. We approach that in a completely different way. As we start with the issue. You've had an event. Let's capture everything about that event. Let's reduce the noise immediately, and then now let's automatically categorize it. Automatically categorize that out. Let's build up a very intuitive interface to allow you to quickly drill into. I'm an infrastructure guy. Give me the information that's relevant to me. I'm a developer. Give me the information that's relevant to me. I'm a security guy. Give me the information that's relevant to you. So it's all about the data's always the same. How you look at that data is always different. And we approach kind of that logging requirement from a different angle. Why do you keep logs forever? Sometimes it's for compliance. Fine, you're going to keep needing to do that. Most of the time, it's because you've got issues and you want to look into those issues. So turn that around and start at it from an event-driven approach. So capture when an incident happens and then do your troubleshooting, rather than just gigabytes and gigabytes of logs you've got to store and search and so on, which is just an admin nightmare.
And the searching is an issue, right? We've had numerous customers say to us that we have to know what we're looking for in order to find it.
Yeah.
But what happens if you have no clue? It's the first time this has happened. It could take you days, weeks, months potentially to really hone down on this issue, lots of trial and error, and that's just wasted money and time for a business. They should be doing something else that impacts the business. So to add that kind of overhead to this is just trouble and pain for everybody, including the business.
And a lot of customers will come back to us and say, well, that's great, but actually how do I know what an event is? So what we start doing is adding kind of baselining and being able to do analytics against what's normal. So when do you deviate from normal? Because let's be honest, if your normal is 50% CPU, it's just a random metric, and you go to 70%, that can be as abnormal if you go to 20% CPU. Not doing enough on all your workloads is probably worse than doing too much, because it probably means something upstream is broken. So we allow you to do very, very basic, is things high, is things up, down, have I got certain errors? All the normal stuff you'd expect from a monitoring tool. But then start doing actually trigger events and alerts based on what's abnormal. What we normally do on a Monday morning and why are we doing this differently today?
Yeah.
And then create that forensic capture which Ed touched on, so that you can then go and analyse that. And you can analyse it later on. The worst thing, I've been a support guy and an ops guy, worst thing is getting a phone call at 2 in the morning and knowing that I've got a finite amount of time to log into that server and start troubleshooting before that data's gone or that instance is ended. Now with that automated forensics, so I'm capturing that, everything that's happening during that duration. I don't need to wake up at 2 in the morning. I can wake up at 7, still be fixed by the time the business starts, but I don't need to be right there, right then.
So do you think one of the things that becomes important is the way we actually get at the information? Because that's one of the things that's obviously really different. And we just talked about captures at that point in time, and the heritage obviously of Loris, our founder, obviously one of the main creators of Wireshark and what happens around that. Do you think it's the fact that the way the kernel agent works and the ability for us to actually get at information that's the real source of the information, where perhaps other tooling is 1 or 2 layers above that information, so they're already having it aggregated before they get to it? Is that pretty important from a technical perspective?
100%, and it's a real problem with kind of extrapolation, and it's the real benefit of containers is that it encapsulates a whole bunch of stuff into something that's easy to transform. The problem with with even some of the modern tooling is from a traditional tooling, you have no idea that that's a container, it's just something that's running. With modern tooling, a lot of the time it's, okay, I'm going to look at that container specifically as a container. So you don't get the visibility of the fact that actually underneath that there's a whole bunch of stuff that maybe Kubernetes is doing, maybe Mesos is doing, maybe the cloud partner is doing as well. If you're in Amazon, okay, what's going on, what's underlying there? Am I getting CPU steal? Am I overcommitting on memory? Within my VMware world, have I got CPU throttling going on? All that stuff that's underneath it is really important. A container, which I think we touched on earlier, but a container is just a process that's running. And the whole container D, the whole Docker engine is encapsulating that in a glorified Chroot jail. But actually, down there at the kernel calls, that's where you can't hide from that. Everything goes to CPU. Everything goes to the system kernel within Linux. Same thing within Windows. Everything happens there, and it's really important to be able to capture that, because otherwise you don't get the full picture.
Yeah.
And again, being able to capture that in forensics, be able to analyse that is really important.
And this, and I think people sort of trusting their orchestrator. People are using AWS, for instance, trusting the orchestrator to actually spin up containers to provide the amount of resource they need from a host perspective within the environment, and without actually utilising information to work out, do they need all this compute? Is it actually being useful? Yeah, they're spending money and they're trusting the orchestrator to just turn stuff up and down when they need it. What we tend to find when we look deeply at what's going on is that there's a lot of over provisioning going on, and you can save money in your AWS costs. And AWS is cheap, so you can save money in that environment and still have a perfectly running, completely safe environment that you can be confident in what's going on with it if you've just got the information.
Yeah.
And so I think we're trying as well to help customers understand where that benefit sits. Do you need to have as much compute as you're using, compute and storage? Can you turn some of that down? Is that saving money? Potentially. It's another area we can help.
Sizing is really difficult. How much CPU memory and disk space does this app need? I don't know. Let's give it lots and see what happens. Most of the time, people don't come back and see what happens. It's running okay with all the resources we gave it, so let's just leave it, because it's our crown jewels. Actually look at it and thinking it's ticking away 10%. We could save a lot of money by reducing that down. Maybe we change the way we auto-scale that up and down. Again, actually plugging in auto-scaling into the Sysdig metrics to allow it to scale out. Scaling and sizing isn't just a factor of CPU and memory and disk and network. Actually, it can be bottlenecks further up and further down. Have I got enough database nodes, read-only nodes, whatever that is? Have I got enough front ends? Have I got enough middleware nodes? Understanding that and working out, okay, I've got a bottleneck here, there's nothing wrong with that. That bottleneck caused by something over here. Or it could be something just from contention to something completely unrelated. That sort of metrics you'd miss with different tooling. A good example of that is APM, where you're looking down a specific code line to see I've got an issue. You identify a bottleneck, nothing wrong with that code line. It's got a bottleneck because it's being contended by an application that's completely unrelated.
Okay.
That's interesting as well, because time and time again we see customers who are also under provisioning. So their process is, we've got a new application that needs to go to market, so we'll provision a bunch of nodes, a load of containers, some node lists, and all that good stuff. And then the next project comes along, right, we're provisioning some nodes and some containers, and they never revisit that. And so they could be running at 90% or 10%, and then so the infrastructure spend just keeps on growing. And actually the value of containers is that we can really, with a high degree of fidelity, actually pinpoint what we should be running and how much of. So we can go back to customers and say, look, you've got a lot of room here. You don't need to spend $50,000 on servers this month. You can just use the stuff you've got already. And so we provide a lot of value to customers around that too, I think.